Good morning. This morning we're going to be looking at orbital notation rules. So we learned electron configuration and about the subshells and the electrons within them and how many they can hold. So what we're going to do is we're going to draw the different spins of the electrons now. So one of the rules we have is Hund's rule. So Hund's rule says orbitals of equal energy are each occupied by one before they're occupied by a second. So on our atoms game that we played on the collisions on level 4, we saw this. It wouldn't let us continue if we didn't have one in each. So, for example, we know that P has 3 orbitals in it. So if I have carbon, that we have here as an example, carbon has 6 electrons. So 1s2 is full for both of them. 2s2 is full. That's 4 electrons. It has 2 more. So within each of these suborbitals, you have one. If you cannot put 2 together and leave the other 2 empty. It's okay to have one by itself, but you have to space them out evenly before you can go back and add a second. The second rule we have is the Pauli exclusion principle. So it's a maximum of 2 electrons can be in each orbital. So like this only holds 2. Each line holds 2. But they have to have opposite spins. So if you see these are going in opposite directions. So if you have this is correct, this would be incorrect. The second one should be facing down. The middle here is correct. The third is incorrect. So you have to have opposite spins or opposite directions of where the electrons are going in. So we're going to go ahead and practice on some orbital notations. And we're going to have to use either the chart method or your periodic table, one of the two. So if we have, for example, oxygen. If we were to use our periodic table method, we have energy level 1, 2, 3. Oxygen is in period 2, so you're going to stop at energy level 2. We have our S block, our D block, and our P block. So to start, if we're using the periodic table, we're going to go 1s1, 1s2, so 2 electrons. Then we have, you say 1s2, 2s1, 2s2. So we have 1s, 2, and 2s2. Then we're going to go to P block, 2p1, 2p2, 2p3, 2p4. So we would end at 2p4. So 1s2, 2s, control period 2, 2p, control period 4. And then you'll notice that all of the electrons add up. So you have 2 plus 2 is 4, plus 4 is 8 electrons. Oxygen has 8 electrons. Another way to also check, in energy level 2, oxygen should have 6 valence electrons. It's in group 6, so that matches as well. So what we're going to do for orbital notation is you're going to copy the arrows over here. And you can do one arrow at a time if you'd like. So you can copy and paste, and then drag your arrow over. So you start here. So we have 1s has 2. So you can copy the whole thing if you'd like to. This just is step by step. So here's 1s1, here's 1s2. That's what 1s2 would look like. Then we have 2s2. Like I said, if you want to do it like a shorter way, since you already know, you can copy and paste. Here's 2s2. So now we have a total of 4 electrons. Here, you have to put them all going up before you can go back and go down, because we have 4 total. So what that would look like is you can take this one here. So you have 2p1. And I'm just doing control, copy, and paste. 2p2. 2p3. And this way, here is our 2p4. So I'm not putting that second one in until each one of these has 1. Let's go try the other method for our aluminum right here, the zigzag way. So aluminum is in the 3rd energy level, and it's in group 3. So it's going to be right here where my cursor is. So we're going to zigzag down until we add up to 13 electrons. So we're going to start with 1s2. So 1s2 is 2 electrons. 2s2, we now have 4. 2p6, 6 plus 2 is 10. Keep going. So 10 plus 2 At 3s2, we're up to 12. So we're not quite there yet. We're going to go to 3p. So if I have 12 and I just need 13, it's going to be 3p1 as our final notation. So 1s2, 2s2, 2p6, 3s2, and then 3p1. So now we're going to go in and fill in our orbitals. So we got to start here at energy level 1 and work our way to 3p. We know energy level 1, s2, has 2 electrons for the exponent. So we're going to paste, oopsies. We're going to paste 2 electrons. You can do one at a time, like I said, but you can paste 2. So here we have 1s2. And then we have 2s2 comes next. Then we have 2p6. So remember for this one, you have to go and add 1 and then go back and add the second. So here's 2p1, 2p2, 2p3, 2p4, 5, and 6. So it's 2p6. Then next we have 3s2. Then we have 3p1. So this is what aluminum is or represents. And you'll continue to do the same thing on part 9. You just have vanadium, it's slightly larger. And then answer the question. The energy of the 4s orbital must be higher or lower than the 3d. So this is thinking, why do we skip 3d and do 4s first? So would the energy in 4s be higher or lower? And then if you need additional supports, there's some really good notes here on this link. And then this one goes over most of day 1 that we did last class. Here's the periodic table way, and this is orbital notation that I just went over. Just a little bit of review here. But that is the end of the notation fill-in notes.